Hi guys, this is Sir Eldon Calamba. So this is another discussion before our sample problem. So let's start. Welcome to another discussion of physics. We will now be having motion in one dimension. Okay? For all we know, motion takes in a given place. We call it as a space. Okay? And then motion takes place in a space throughout time. Hence, we have here what we call space-time na dimension. Okay? But for that one to make sense for us, we go to the basics first. Let's now have let's simplify that idea of space and time. Let's have that called as a motion. Okay, we will now be having motion in terms of distance, displacement, acceleration, velocity, and so on and so forth, because that's the basic understanding for us today. Let's have this idea wherein we have here, I will go directly we have here a particle that is seen at different instances, at different points. Okay? And we have it laid in one dimension lang along the x-axis. So you have here 0 meter, 1 meter, 2, 3, -1, -2, -3. Wherein we can see the particle at 0 seconds, nandito pa siya at 10 meters. After 5 seconds, nandito sa 2 meters. 10 seconds, -1 meter, and then 15 seconds, -3 meters. From our understanding, let's say for example, when you are driving a car, we are just after distance and then we're just after the speed. But sad to say, here in physics, we have different quantities you have to consider. That's why we have the velocity, and then not just speed, we also have the displacement, we also have the position. Okay, let's start with distance. We denote distance here, distance as x muna. So it is measured from the origin or from the initial point. So let's say for example, at this t is equal to 0 second. Obviously, that is our initial point. And then at initial, it is at 0 meters. That's our origin. Okay? And after such time, let's say for example, 5 seconds, it is now seen at this point. Okay? Now, it is at 2 meters. How do we know if it is the distance? So, sinabi dito, measured from the origin. So, coming from this one, going here, that is already our distance. So, we could denote this as x already. I will just change. Okay, yan siya. This is our distance. That's x. Wherein x, for x, this is just equal to 2 meters. Okay, now, how about after 15 seconds? Is it still 2 meters? But no, obviously, it is at -3 meters. So, parang, it is at the left of our origin. But, we have to take note that we are still after the distance. So, we have to consider everything from 0 second going to that 15 second na mark. So, measured from the origin, it is not just simply measured galing dito, going here. No, that's wrong. It is the actual path, the actual measurement, measured from the origin, from the very beginning. So, it should be measured going from 0 second, going to 5 seconds, going to 10 seconds, and then 15 seconds. Okay, so it will not be just 3 meters. Unlike dito sa ating x na at 5 seconds, that is 2 meters. Iba. Okay? So, for us to get the distance, I will just have this x at 15 seconds. In order for us to get that one, we have to consider the total path that is taken. So, coming from here, from 0 second, going to 5 seconds. Okay? So, let's have that as x1. Okay? So, x total is just now equal to x1 pa let's have x1 plus, ah, ga, from 5 seconds, bumalik siya, pumunta siya kay -1. So, paano ko ito sulat? Let's have this, galing dito, 5 seconds. So, punta siya dito. Okay, let's have that as x2. So, plus x2. And then, after pa naman kay 10 seconds, pumunta siya kay 15 seconds, pumunta siya dyan kay -3 meters. So, galing kay 10, punta siya dito. So, let that be x3. So, as you can see, x total now is just equal to x1 plus x2 plus x3. But, ano yung x1, x2, at saka x3? Nakita na natin anong value ni x1 actually. x1 for us, that is just 2 meters. Plus, how about that x2? Okay, tingnan natin ito. So, kung x2, it is coming from 5 seconds going to this point at 10 seconds. So, from 2 meters, naging -1 meter. Pero, distance is not a vector quantity. There's no negative sign for this one. So, magbilang tayo. So, from -2, punta siya kay, nag-travel siya papunta dito. So, you have 1 meter already. And then, punta siya dito na naman kay 0 second. That's another 1 meter. And then, punta siya dito kay -10. That's another 1 meter. So, ilang meters ang na-travel niya? So, that's 1, 2, 3. 3 meters. So, x2 is actually equal to 3 meters. So, plus 3 meters. Plus, kay x3. So, galing kay 10 seconds, papunta kay 15 seconds. So, that is just -1, -2, -3. So, that's just 2 meters all in all. So, this is 1 meter and another meter. So, 2 meters. So, meaning, the distance na na-travel ng ating particle going to that 15 seconds is 7 meters. So, that is our distance. The total distance na travel ng ating particle. Not just -3 meters. Kasi iba yung -3 meters or iba yung 3 meters. Okay? We now have that as position, yung negative niyan. Okay, so magnitude is equal to the object's distance from the origin. It has direction which is with respect to the origin. So, ito na ngayon yung idea na meron kang pa left, meron kang pa right, meron kang positive, meron kang negative. And we denote it as x na may arrow on top. So, we could have again here, say for example, dito na lang muna. We have there x1, we have here x2, and then we have here x3. Yan. So, measured from the origin man kaya. So, x1 for us is just equal to measured from the origin. So, 0 meter going to 2 meters going to that 5 seconds. So, that's just 2 meters. And we have x2. That is obviously 1 meter left of the origin at the 0 second mark. That is -1 meter. And then we have x3. That is just equal to -3 meters. That's 3 meters to the left of our origin. Okay? So, wag malito kay distance at saka kay position. Iba-iba ang kanilang idea. Okay? Distance is a scalar quantity. It's the total or the actual path taken by our object or by our particle. While our position, it is still measured from the origin, but it should have a direction. Regardless if pumunta siya initially kay left, tapos pumunta ka kay right. No. It is the point wherein our particle is being situated at that moment in time. So, as you can see, at 5 seconds, x1, that is equal to 2 meters. And then at 10 seconds, x2, that is -1 meter. Okay? We now have this one, displacement. Displacement is just the change in position of our particle. So, if change in position, it is always, what do we call this? It is always comparing the final point with respect to the starting point or to the initial point. Okay, so delta x or change in x is just equal to the change in position dito ko na isulat. That is equal to the final position minus the initial position. Okay? So, let's say, for example, from 5 seconds to 10 seconds. What is the displacement from T? Oops. Displacement from T is equal to 5 seconds to T 10 seconds. So, we have to know the initial and then the final point. Obviously, ang ating initial point, bar ko na lang. Ang ating initial point is this 5 seconds. And then, that is 2 meters to the left of our origin. So, this is positive 2 meters. And then, the final point, that is 1 meter, 1 meter to the left of our origin. So, this is negative 1 meter. So, delta x for us, or the change in position, that is just negative 1 meter minus positive 2 meters. Okay? So, that will give us, calculator natin. So, negative 1 minus positive 2. So, you have negative 3 meters. Ayan. You have a displacement of negative 3 meters. And how do we draw that displacement vector? So, that displacement vector is just coming from 5 seconds going to the 10 seconds, or from 2 meters going to negative 1. So, displacement vector natin will be this one. Let's obviously, the tail of our arrow is coming from the 2 meters. And then the head is going or pointing towards the 10 seconds. This is your displacement vector. Okay? Now, before I go to the next one, let's have the position vector na naman. Position vector muna. The position vector is measured from the origin. So, ang position vector natin, x1, is galing kay origin, going kay 2 meters. That is your position vector x1. And then, position vector x2, still from the origin. Oops, ibang color na lang. This is our x2. And then, x3, coming from the origin pa din, going to that 15-second mark. So, this is your x3. Okay, so, that's how we draw our displacement and position vectors. Sorry, displacement and position vectors. Okay? So, we now go to this new concept. We have, not new, but old. Okay, but we will be having speed. Okay, before I go to the idea of speed, we have here average and instantaneous values. When we say average, we talk about a very, very big data wherein we just have to get the mean of the data so that we could have one value. Wherein, while our instantaneous values, it is a specific value wherein at that point, let's say for example at 5 seconds, that is the value of our let's say for example acceleration or of speed. That's very specific. Kaya nga siya instantaneous at that instant. What is its value? So if you have an average wherein you have 5 datas, you get the average or divided by 5. So from 0.1 to 0.5, you have to get that 1 for the average. While sa instantaneous, you have to look at the very specific data at 1, 0.2, 0.3, 0.4, and 0.5. Okay? We now have this idea of speed. Let's say for example, at 0 seconds, you're at the origin. And then you walk. After 10 seconds, nasa 4 meters ka na. It's very easy to talk about the average speed. Kasi sa average speed or speed natin sinasabi na, I just have to measure my distance na na-travel. And then divided by the time na it took for me to travel or to walk. So that's total distance divided by the total time. But for instantaneous velocity, it's kind of different. It's very specific. Because as you can see with this one, with this figure. So, let's say for example, ikaw tong particle na to, x1, ito dito, position x1, not position, this, sorry, wag muna position. Let's talk about distances muna. So, galing from x1 to x2. you have traveled total distance, okay? But you only have to analyze 2 points lang, okay, for you to get your average speed. But iba ang idea if you have the instantaneous value. Kasi yung tinatanong kay instantaneous value is that at this point, ano kaya ang speed ko? Let's say for example, 1 second yan siya. At that 1 second, what is my instantaneous speed? At let's say for example dito, at t is equal to let's say 5 seconds. Anong instantaneous speed ko? It's very specific. Okay, so it is as if na paliit ng paliit ang ating interval na kino-consider. That's why our instantaneous velocity, sinasabi natin, it is the positive x interval divided by delta t wherein the limit delta t is approaching 0. Later on, sa graphical description, you'll realize that ganito pala ang ibig sabihin yan. Okay? So, saan natin yung nakikita yung average at saka yung instantaneous values na yan? So, in your car, you have a speedometer. That speedometer actually gives you your instantaneous value ng speed or instantaneous speed wherein every time na titignan mo ang speedometer ng sasakyan mo, it gives you the instantaneous value. Let's say for example, you're going from your house going to SM or from your house going to the mall. If going to the mall is it will take you not 5 hours siguro. Let's say 15 minutes. So ang average natin dyan is the total distance na it took you going from your house to the mall divided by that 15 minutes. But ibang usapan si instantaneous speed. So let's say for example traveling ka na at the 10 minute mark, tinignan mo si speedometer at pagkakita mo kay speedometer is merong value. Obviously, meron kasi umaandar ang sasakyan. So, that's your instantaneous value. Let's say, for example, 30 kilometers per hour. Tapos, after siguro, let's say, at 12 minute na mark, tinignan mo ulit, naging 20 kilometers per hour na lang. So, instantaneous value is also changing. Kasi nga, different times could give you different values of instantaneous speed. Pwera na lang if constant ang ating average speed at saka ang ating instantaneous speed. Meaning to say, constant acceleration. It is not changing. Okay? Later on, we will have that one again. Okay. So, we will have this graphical, that's the average velocity, average speed at saka instantaneous speed ha. We now go to the graphical descriptions of motion. We will be talking here about in terms of velocity because we have to take account for the direction where our car goes, where our particle goes, may it be left or going to the right, going up or going down. But mind you, we are still in one dimension, so puro x lang muna tayo. So, we have here a position versus time graph or an XT graph. See, position versus time graph, it's kinda scary tingnan, but we could actually get some information about this one. So, ang ating horizontal is time, horizontal axis is time. Our vertical axis is our position. I'll always label them ng time at saka position, and then I always put the unit seconds for time and then position for meters for position. As a unit lang muna tayo, seconds, tsaka meters. Okay? If kilometers yan siya, so you have to convert if anong hinihingi sa problem. So let's have this one. You have here the graph. It's kind of complicated tingnan, I know. So as you can see, from 0 second to 2 seconds, straight lang siya. While from 2 seconds going to 6 seconds, nagdiagonal. Same thing from 6 seconds to 10, and then 12 to 14, and 14 to 16. It does not mean na ang particle natin is nag-straight line lang siya, and then pumunta sa taas, tsaka bumaba, nag-straight line, tapos bumaba, tapos bumalik sa taas. No. This is one dimension lang ito na position. You can treat this as your x na mga position. So, you could lay it up here na paganyan. Okay? So, let's say for example, from 0 seconds to 2 seconds, nasa 3 meters lang siya. So, nandito lang ang ating particle. Ayan. And then, after, let's have this as A. Line A, position A. Ayan. And then, after 6 seconds, nasa 6 meters na siya. So, nandito daw siya. Ayan. And then, after naman ng 6 seconds, punta tayo kay 10 seconds, bumalik siya. Pumunta siya kay 0. Ganyan. So, nakita natin, so this as B, and then C. Nakita natin actually na galing kay 3 meters, nagstay pa dyan ang ating particle for 2 seconds. Kasi from 0 to 2. Ito, straight line from 0 to 2. So, nagstay lang siya dyan. But after the 2 second mark, hindi siya pumunta sa taas pumunta siya kay 6 meters. So, nag-move forward siya. Okay? So, meaning, nag-move forward, naglakad lang siguro, and hanggang dumating siya kay 6 meter na mark. And then, after that 6 seconds, hindi siya bumaba, but bumalik siya. Tapos, nasobra pa nga. So, after 10 seconds, nasa 0 meters position siya. So, galing dito kay A, punta siya kay B. Nag-walk, naglakad naman siya pabalik. Galing kay B, papunta kay C. Okay? So, it is actually laid out in one dimension lang. Okay? Kasi, ganito lang pagka-represent kay position versus time graph. Because, this could give us different information actually. Okay? Let's start with the slope. The slope of the position versus time graph will actually give us velocity. At saka dalawang klaseng velocity. We have the instantaneous velocity and then the average velocity. Okay. So, let's have this one again. So, ang slope. Slope is just equal to rise over run. So, that's just, eto, position lang ito ha. So, delta x, over delta t, the change in time. So, meron akong x2 minus x1 over t2 minus t1. And this is actually your average velocity. Or if you want, sige, general muna, velocity. Okay. Now, as you can see, this is just equal to, should be black. Wait lang. It's just equal to delta x over delta t, or the displacement over the change in time. And then, ang SI unit natin for this one is in meters per second. Sometimes, yung iba, kilometers per hour. Okay lang din yun siya. Okay. Now, that's our average value. That's our average velocity. Now, let's solve this one. It's kind of complicated, ang position versus time graph natin. We have here the other value. That's the instantaneous velocity. Again, when we say instantaneous velocity, it's very specific. Okay? Kasi kung average velocity lang, balikan natin ito ha. Kung average velocity lang, ang kino-consider lang natin is dalawang point. From this point A, going to this point B. Okay? So, you could get actually the average velocity. But for instantaneous velocity, it's very specific. At that point, ano kaya ang aking instantaneous velocity? So, we will now have the instantaneous value. So, how do we get that instantaneous value? So, still, slope. But let's take a look at this one. As you can see with this average velocity, it is 2 points, right? If you have a curve, and then if you're going to get an average value or average velocity rather, is that we're actually getting the slope of our secant line. But for instantaneous velocity, it's different. We have to get the slope of our tangent line. So, tangent, it should be touching at 1 point lang. So, ang idea nito is the same with our instantaneous speed. So, delta x over delta t, wherein the limit delta t is approaching 0. Or this is just equal to dx over dt, finding the first derivative. So, ang nangyari dito is that paliit ng paliit ang ating time interval. If paliit ng paliit ang ating time interval, same, paliit ng paliit lang din si delta x. So, as you can see with this line, that secant line, if kukunin natin ang slope, delta x and delta t, could get the average. Paliitan pa natin, so naging ganito, paliitan pa wherein it will just be touching at one point lang. Eto na yan siya ngayon. So, touching at one point. So, instantaneous velocity is just equal to the limit delta t. Instantaneous velocity is just equal to delta x over delta t, wherein the limit delta t is approaching 0. Or for us, ang alam natin for this one, instantaneous velocity is just equal to dx over dt. Okay, finding the first derivative. I will not be discussing anymore the derivatives. Okay, I believe so that you already know how to find the first derivative, the second, or even the higher order derivatives. Okay,